Hello everyone. In this video, I'm going to go over how to do the homework on chi-squared test for independence. So in the first sheet here, we have 3 sheets. In the first sheet, gender versus student employee, it says the table above shows 299 randomly selected SU students according to their gender and whether they are a student employee. Is this enough evidence to conclude that the variables gender and student employee are not independent? Okay, so we're just going to go through the steps of the test, which I put the procedure in here for you guys. And we're going to fill out our answers over here in the green places. Oops, I actually started doing it before, so let me just take those out. And I'll show you guys how to calculate the p-value and all of that. So the first thing is we need to check the assumptions for the test. It's very simple this time. It just needs to be a random sample. And so let's check our question over here. It does say that these were randomly selected SU students. And I randomly selected them myself using a random number generator, so I know that it's really a random sample. There is actually another assumption that's kind of hidden within step 4 here, where you might actually have to stop and not perform the test. But for the assumptions that we check ourselves, it's just whether it's a random sample. Okay, the alternative hypothesis, there's only one possibility. It's just that the two qualitative variables are not independent. So our 2 variables this time are student employee and gender, and we're trying to show that these are not independent. You can also extract the same information from the sentence in the question. So is there enough evidence to conclude that? And then the rest of the sentence is the alternative hypothesis. So the variables gender and student employee are not independent. That means the null hypothesis is going to be the exact opposite. It's going to be that they are independent. Okay. Steps 1 through 4, we need to make a copy of this contingency table and then figure out what the entries would be if these variables were independent. So I'm just going to select the whole thing and paste it over here. And then I'm going to label this expected values for independence. And so basically the idea is we figure out what these entries inside the table, not including the totals, would have been if the variables were independent. So if they were independent, then the numbers in each column should match the proportions in the total column over here. And the numbers in each row should match the numbers in the total row down here. And there's an easy way to figure out what the right numbers are. All you do is this little formula, row total times column total divided by table total. Okay, so I'm going to go into each cell and I'm going to type my own formula. It's equals. Then I'm going to use the arrow keys because I think that's faster to go down to the column total, asterisk for times, and then arrow keys again to go over to the row total, and then slash, and then go to the table total. Okay, and then hit enter. And I'm just going to do that for each of the cells in the table. So column total times row total divided by table total equals column total times row total divided by table total equals column total times row total divided by table total. Okay, and you should see that these numbers look kind of similar to the real numbers, but how far off they are from the real numbers is what tells you your p-value. Okay, so Excel is actually going to compare the numbers in the real contingency table to the ones that we would have if the variables were independent, and then it's going to calculate a probability based on that. So in the background, there is actually a thing called chi-squared that is being calculated, but we don't actually get our hands dirty with calculating that ourselves. Okay, so all we need to do at this point is just check this one little extra thing. If any expected table entry is less than 5, stop and do not perform the test. So that is just making sure that the distribution of like the sum of squared errors basically between these actual values and expected values would really have a chi-squared distribution. And again, I don't have time to go into the details about all that. But if you get any numbers less than 5 over here, then you should not perform the test. But we did not see any like that, so I'm going to answer no down here in the next question here, which says, are any entries less than 5 in the expected table for independence? Okay, now I'm going to actually calculate the p-value. So the formula for the p-value is equals chi sq dot test, And then there's two things that you need to plug in. So the actual range and the expected range, and explained in the procedure over here too. So for the actual range, that is the entries in the table, not including the totals. So those inner entries. And then that's the actual, and then you put a comma, and then you do your expected range, and that is the entries in the expected values table, not including the totals, so just the numbers that we calculated. And then close parentheses, hit enter, and that is your p-value. This hashtag error just means the column is not wide enough, so just widen it a little bit. Boop, there we go. Okay, so I'm seeing that the p-value is not very small. So the interpretation of what this p-value means is this is the probability that if the null hypothesis was true, so if gender and student employee really are independent, that our real contingency table that we have, this one, would look as different from the expected one for perfect independence as it does. And that's about a 12% chance. So you guys can see yourselves, like these numbers, 97, 72, 86, 44, they're not that different from these numbers over here, 103, 65, 79, and 50. They're off by about like 5 to 8. So that's kind of, the idea here is basically like that's close enough that it could just be a little random fluctuation from the particular sample that we grabbed. Yeah, and then so the probability that our numbers that we got would be as far off from the perfectly independent ones over here as they are if they really were independent is 12%. So if something with a 12% probability of happening happens, I'm not that surprised by it. So I think this is not a small enough p to reject the null hypothesis. So I'm going to do the interpretation for when p is not very small. So my interpretation statement here is going to be with a p-value of 0.12, there is not enough evidence to conclude that the variables gender and student employee are not independent. Now you also cannot conclude, I mean, this doesn't necessarily mean that they are independent, we just were not able to conclude that they're not independent. It's this p-value is always a hypothetical probability. This is the probability of what would happen if they were independent. We never actually calculate anything like a probability that they are independent or that they aren't independent. All this hypothesis testing is all kind of, it's a little bit strange, you know? Okay, let's look at first gen versus varsity. I mean, it's strange, but I should say, like, this is kind of the best we can do with the data that we have. Right, so now first gen versus varsity. So now we have 300 randomly selected SU students according to their first gen status and whether they are a varsity athlete. First gen means that their parents did not complete college. So they're the first in their family to complete college, basically. Is this enough evidence to conclude that the variables first gen and varsity athlete are not independent? Okay, so we're going to follow the same procedure. It's the same sample. Actually, I just had to eliminate, I think there was like one person from this sample that didn't put male or female. So if I didn't eliminate that category, then we wouldn't have been able to do the test. So I just included the ones who said male or female. Right. So for this one, yeah, it's still a random sample. So we're going to say yes. The alternative hypothesis, I'm going to pull that out of the question. Is this enough evidence to conclude that? So the alternative hypothesis is going to be the variable first gen and varsity athlete are not independent. And that's going to make my null hypothesis the opposite, that they are independent. Okay. Now for my steps 1 through 4 to get my p-value, I'm going to make a copy of this table. I'm going to label it expected values for independence. And now I'm going to delete these inner entries, not including the totals. And then I'm going to use the totals to reconstruct what these values would be if the variables were perfectly independent. So I'm going to do equals column total times row total divide by table total equals column total times row total divide by table total equals column total times row total divide by table total equals column total times row total divide by table total. If we had a better statistics program that we were using, I mean, I think all this stuff would be done for us as well, but kind of making do with Excel here. Like, we have to do this part for Excel because it's not programmed to do this for us. Unless maybe there's some extension that does. Okay, anyway, getting back to it. Just looking at these numbers here, the independent ones and the real ones, like, those look pretty similar to me. They're only off by about 3 or 4, so I think we're probably not going to be able to show that they're not independent. But let's go ahead and check the rest of the test. So are there any entries less than 5? Oops. No. Calculate the p-value here. So I'm going to do equals chi-square dot test. And then I'm going to select my actual range, which is the inner cells, not including the totals in the actual table, comma. Now I'll select the inner cells, not including the totals in the expected values for independence table. Close parentheses. Close parentheses, hit enter. Widen this, widen. Okay, so this is my p-value. And once again, this is pretty big p-value. It's not enough to, this is not small enough for me to be shocked about anything. So I'll say with a p-value of 0.29, there is not enough evidence to conclude that, and then I'll put the alternative hypothesis, the variables first gen and varsity are not independent. Okay, so they might be independent. I can't really tell. I don't have any way to conclude that they are not independent. So they could be independent. All right, so we got no conclusion basically for this test. And the last one here is GPA versus year. Okay, so looking at this table, it's much bigger. I'm already kind of dreading like, oh, I have to type in 16 formulas. But look at this little corner over here that's got all these zeros in it. So I'm thinking when we make our copy table, these entries might end up being less than 5. And if that's the case, I don't need to do all of them. As soon as I see that one of them is less than 5, I'm going to stop and not perform the test. Okay? But we can still do the other steps until we get to that part. So this is the 300 random SU students again. So yes, it was random. The alternative hypothesis is the variables GPA and year are not independent. Put that here. Null is that they are independent. Okay, and now we're going to do the copy table thing. Okay. Oops, I forgot to copy the formatting. There we go. Now I delete the inner entries, not including the totals, and I'm going to start my reconstruction from like the bottom corner over here and just see if I can get one that's less than 5 so I can stop. I'm going to do equals column total times row total, divide by table total. Boop. Okay, it's less than 5, so I should not perform the test. So I'm going to go ahead. Are any entries less than 5? I'm going to answer yes, stopping test. Okay. So I will try to give you very clear instructions on any quiz or test as to whether you should continue and do the p-value or stop and not do the p-value. Sometimes I ask you guys to continue even if you found that you should stop, just so that you get partial credit in case you were wrong about it. So I'll be very clear about that. And yeah, that concludes this homework video. Hope it made sense. If it didn't, send me an email or come to office hours. Toodaloo!